So now let's discuss the derivative by definition of a power function. So the question states that we have to find the definition by derivative, by definition the derivative, or by principle the derivative with regards to x of the following function, which is 2 over x to the power 4. So basically that means that we take y as y is equal to 2 over x to the power 4, and this will be our first equation. And so let's take the first step, which is to increment on both sides, which means that basically this y will become y plus delta y, and every place with an x will be replaced with x plus delta x. So this x to the power 4 becomes x plus delta x whole to the power 4, and this 2 remains as it is because you cannot take an increment of a constant, and 2 is a constant. So when you take this y to the other side, to the right hand side, it becomes minus y, and now you have an expression for delta y in terms of x and y. So this is now equation number 2. And so the second step was to put the value of y from equation 1 into equation 2. So this y becomes 2 over x to the power 4, 2 over x to the power 4, because y is equal to 2 to the x power 4 as in equation number 1. So now what you'll do now is you'll take the LCM of this term and this term, and so this 2 will be multiplied with x to the power 4, and this 2 will be multiplied with x plus delta x whole to the power 4. Now this eventually becomes this entire equation, and so when you basically combine the two, this is what you get. And then now you'll basically take 2 common in this term and this term, and so you'll get 2 into x to the power 4 minus bracket open x plus delta x whole bracket close whole to the power 4. So basically this is the entire equation now. So you can take this 2 outside, obviously, and then you can basically take these two terms, this one and this one, in terms of square. So this x to the power 4 becomes x square whole square, and this x plus delta x whole to the power 4 becomes x plus delta x whole square. So I'll take the whole square, and now you can apply an algebraic identity on this, which was this algebraic identity: a square minus b square is equal to a plus b into a minus b. So basically you'll treat this x square as a, so x square whole square becomes a square, and you'll treat this x plus delta x whole square as b, so this x plus delta x whole square becomes b square. And so you'll translate it into this form: a plus b into a minus b. And when you do that, you get this. So this now becomes x square minus x plus delta x whole square into x square plus delta x whole square. And so now what you'll do is you'll expand the x plus delta x whole square terms in both of these. So basically this, you'll expand this and you'll expand this, and you'll apply the algebraic identity, which was that a plus b whole square is equal to a square plus 2ab plus b square. And when you'll apply this algebraic identity on this, you'll get x square plus 2x delta x plus delta x whole square. And basically now what you'll do is when you open this bracket, so basically this negative sign will be multiplied with all of these terms inside the bracket. So this now becomes x square minus and also one important thing, you'll not expand this one, because what you need to, because if you even expand this, it will not matter, because this is a positive sign, so x square will just be added into the x square that you get from this term. You will have to expand this one because this results in this x square minus x square, so you'll basically cancel out these two terms. And so what you get is this. And now let's move ahead. What you'll do now is basically you when you further simplify this, you get this. And so dividing both of these sides, the third step was to divide both the left hand side and the right hand side by delta x. This can no longer be further simplified, so you'll go to step 3, and so now delta y over delta x, and this will become 2 over delta x and all of this, whatever this is. So now what you'll do is you'll cancel out the delta x over here and the delta x over here, and so you're left with this. And now you'll go to step 4, which was to take the limit as delta x approaches 0 on both the left hand side and the right hand side. And so now this is what you get. Now, as you remember, this is the complete form of the derivative of y with respect to x. And so you'll apply this limit as delta x approaches 0 on this whole thing, this entire bracket. And so when you do that, basically you'll replace everything with every delta x term over here with 0. So this now becomes 2x plus this delta x becomes 0, and so this delta x becomes 0 and this delta x becomes 0. So this is what you get as a result. And when you solve this, when you do all the calculations, you end up with this in the end. And now, well, when you basically when you add x squared and this x squared, you get 2x squared. And so now what you can do is, this is what you'll end up with eventually. And upon further calculation, you get 2 into minus 4x cubed over x to the power 8. This x cubed and this x to the power 8, obviously it will become 8 minus 3 because it's being divided. And so you'll get minus 8. When you multiply this 2 into this minus 4, you'll get minus 8, and this becomes x to the power 5. So dy by dx becomes minus 8 over x to the power 5. And so this is what you just have to do.